Hey y'all, this is the progress check on AP Classroom. This is the second part, so part B. This first question is giving us a parametric equation. So we've got one equation that describes the motion with respect to x, so where is its position left to right? And we've got another one that's describing its position up or down, and it wants to know the speed of the particle. So speed is absolute value of velocity. Velocity is the derivative of position. So I know I need to do derivatives. So I do the derivative of the x. I get 3, well, it's t squared, but, whatever. 3t squared plus 2. And then I do the derivative of y, and I get 10t. So now I've got the equations for the derivative. I want to know the derivative at 3. So when I plug 3 into each of those, this tells me that the particle is moving 29 at a speed velocity of 29 units per second, whatever, to the right, and it's moving up or in the y direction at 30 units per whatever the time is. So I've got each of these broken up into the different directions, but I want to know the overall effect. So I've got the change in x is 29, the change in y is 30, but this isn't just moving horizontal or just moving vertical, it's moving diagonally. So if I know that the x is changing by 29 and the y is changing by 30, how can I get the overall change of the particle or airplane or whatever it is in this case? Well, that's a Pythagorean theorem. So the change in x, the change in y, and the actual movement make a right triangle. So do the Pythagorean theorem and you get 41.725. On the second question, this one is asking total distance. So distance is the integral of position. It's the sum of all the change in positions. So I'm given the derivatives. So I need the integral from 0 to 1.5. And the distance traveled, so if this particle started here and it did this, how far did it go? Well, I need to add up all of the distances along this curve. So when you're dealing with parametric equations, the total distance is the arc length. So how do I find the arc length for a parametric function? Well, it's the square root of, arc length is the integral of the square root of the dx squared plus the, that's not the way that I wanted to write that. Take the derivative of the x, take the derivative of the y, square them, add them, take the square root, and then do the integral. So that's where this equation came from. There's the derivative of x squared. Here's the derivative of y squared. Add them, do the square root, do the integral. This was a calculator problem. So after you got that much done, type it in the calculator, and there's your answer. On this problem, polar curve is defined as r with k as a constant. For what value of k is the instantaneous rate of change? Wait, instantaneous rate of change is derivative of r with respect to theta. So this is asking me for derivative of r with respect to theta. It's asking for dr d theta. So I've got an equation that has r's and thetas in it, and I want to know the derivative of it. Well, I've got theta to the k power. K is just a number. So how do I do derivative when I have a variable with an exponent that's a number? Exponent times the number in front, subtract 1 from the exponent, and then exponent times the number in front, subtract 1 from the exponent. So there's the derivative. And then it's asking me if theta is equal to pi. So I can plug in pi for the thetas, and I want it to equal 15. So then this just becomes an algebra question. For me, if I were taking a test, this would be a guess and check question. So could I solve that? Probably. but I could type in 1.174 pi to the 1.174 minus 1 plus 4 pi and see if it equaled 15. And it does not. So then 1.451 pi to the 1.451 minus 1 power plus 4 pi, that does equal 15. There's your answer. So you had to do the derivative yourself. You had to plug in pi for theta. You had to set it equal to 15. And then at that point, plug in answers and guess and check. Or you could graph it, like put one equation in Y1 and the other in Y2 and see where they cross if you wanted to do that
Joey
too.
Norris, come to the attendance office. Your ride is waiting on you. Joey Norris.
I've restarted this video twice because of announcements, and I'm not doing it again, so y'all just get to hear the announcements. Sorry. So what is the area of one petal of the polar curve? So I know area is integral. Area with polar is 1/2 the integral of r squared. So I've got r. So I can write my equation r squared. I know the 1/2. So the only question really is, where does one of those petals start and where does one of those petals stop? When I'm looking at this graph, the points that are easiest to pick out are the ones here at the origin. So when does it have a radius of 0, and then make a loop, and then have a radius of 0 again? So if I'm asking when does it have a radius of 0, I'm asking, the equation is r equals. So if it's r equals sine 7 theta, my pencil is not working real well, sorry. And I want to know where r is equal to 0, then that becomes 0 equals sine of 7 theta. Where is sine equal to 0? Well, sine is equal to 0 at 0, pi, 2 pi, blah, blah, blah. And then you divide by 7, so you get 0, pi over 7, 2 pi over 7, 3 pi over 7, and so on. So if I were to just double check, if I plug in 0 for theta, when theta equals 0, then r is going to be sine of 7 times 0, which is sine of 0, which is 0. Okay, so I've got a point at 0, 0. The radius is 0 when the angle is 0. I'm going to pick something between, I don't know exactly what pi over 7 is off the top of my head, but I know pi over 6 is 30, so pi over 7 would be a little less than that. If I were to plug in maybe pi over 14, then that would be 7 times pi over 14. So pi over 14, 7 pi over 14 would be pi over 2. The y-coordinate for pi over 2 would be 1. So when theta is pi over 14, so some really small angle, I get a radius of 1. So that's probably like around here. And then if I were to plug in pi over 7, then 7 pi over 7 is pi. The y-coordinate for pi is 0. So I started at 0, 0. I went out to a radius of 1, and now I've gone back to a radius of 0. So that's how I figure out the interval, the limits for my integration. So I need the integral from 0 to pi over 7, and then the area formula, and then type it in the calculator, and that's it. One of the things on this one that I wanted to make sure I pointed out to y'all is when you guys are finding the area of these pieces, the area of these pieces, I'll just draw that again. The area of these pieces is from the origin out at a certain angle. So when I'm looking at the inside, I'm starting from here out to here. So the way that you get all these points is you go at a certain angle, a certain distance, another angle, its distance, another angle, its distance, another angle, its distance, and on and on and on. So all of these are starting at the origin and going out at some certain angle. So we want to know the area inside the circle for sine theta, but outside the circle r equals 3. So r equals 3 is this one, and 4 sine theta is the other one. So I want it to be inside this circle. I thought I would just erase some stuff, but that's going to take forever. I want it to be, I'm wanting this part. Outside the big circle, inside the little circle. So how am I going to get that part? Well, that part is, I need to find where they cross. So where do those two equal each other? I need to know those 2 points. So when I set them equal to each other, 4 sine theta is equal to 3. Then I get sine theta equals 3/4, and then I got my calculator and I did inverse sine 3/4, and I got 0.848. So when theta is 0.848, that's here. Okay, that's in decimal form. I'm not used to that. I'm used to like pi over 2, 7 pi over 6, that kind of stuff. But I know that this angle is 0.848. I need to know what this angle is. Okay, so back to trig. I'm sure y'all are thrilled about that. Back to trig for a second. If this angle is 0.848, then this angle is also 0.848. So the angle that I really want to know here is 180 minus 0.848, so that's 2.294. Okay, so now I've got the parts where I'm going to start and I'm going to stop. I need to do the outside area. That means I'm going to go from 0.848 all the way around until I get to 2.294, and that is going to give me the area of that whole shape that looks kind of like a snow cone. But then I've got to get rid of this part that's inside, the like cone part of it. Well, how am I going to get rid of that part? Well, that part is using the circle, the 3. So I did the 1/2 integral of r squared for the outside one, 1/2 r squared for the inside one, and then I subtract them. So you work out each one individually, and this is a calculator thing, so you subtract your answers and you get 3.246. If that one wasn't clear enough, then ask me questions in class because there was a lot going on in that problem. On this one, a particle moves, so we've got a vector. Yeah, we didn't talk about vectors, so do I just skip this question? Well, no, let's just go with it and see what we can come up with. So I've got vectors. It's talking about acceleration. So what do I know about acceleration? I know acceleration is the second derivative. So we've got position, derivative of position is velocity, derivative of velocity is acceleration. So, I mean, let's just give this a try. I know I need to do a second derivative, and I know I need to plug in t equals 2. So if I do the first derivative of y, derivative of natural log of something is 1 over something times the derivative of something. So I can reduce that. That's 2 over 2t plus 6. I can reduce that to 1 over t plus 3. So that equals this. Or I could rewrite that as t plus 3 to the negative 1. And then when I do its derivative, exponent times the number out front, subtract 1 from the exponent. So there's the second derivative. There's the second derivative of y. And then if I were to plug in 2 to that, well, 2 plus 3 is 5. 5 squared is 25, but it was negative, so the 25 goes on bottom. There's my y. Okay, well, that just cut my answer choices in half. So it's narrowed down to either B or D. If we do the same thing with the x, this is a product rule. So we have the first, derivative of e to the whatever is itself times the derivative of the exponent. So I'm going to have e to the negative t times the derivative of negative t. So there's first derivative of second plus second times the derivative of first. Derivative of t is just 1. Okay, so you could write that a lot of different ways. It doesn't really matter how you do it. You could leave it just like that if you wanted to. But I kind of noticed, hey, both of those have an e to the negative t. So if I were to factor out the e to the negative t, that would leave negative t plus 1. So all of that. You don't have to do that. It's okay if you don't. But I know I'm going to do another derivative, and I just wanted as few parts as possible. So now I did the first times the derivative of the second plus the second times the derivative of the first. And I simplified it, did some algebra. But whether you simplify it or not, you need to plug in 2. Well, if I plug in 2 for t, this one, even if I don't simplify it, is going to be e to the negative 2 times negative 1 plus, okay, that's going to be negative, so I'm going to change that to minus e to the negative 2 times negative 2 plus 1. So when you work all that out, okay, negative 2 plus 1 is negative 1 times a negative makes it positive. Oh, those cancel out. That's just 0. So even though this was presented as a vector problem, it really didn't matter. It was also still just a derivative problem. So I may not understand everything there is to know about vectors, but I do know derivatives. And that was all I needed to know to get the answer. Whew. On this one, which of the following is the best interpretation of? So they are giving us a polar function, polar curve. R is equal to f of theta. So when you compare this to this, 4 is in place of theta. So 4 is the angle. Oh, hold on, let me back up. It said theta is equal to t. So 4 is theta, but theta is also the time. So I need something that says something about 4 seconds. Okay, so t equals 4 seconds. T equals 4 seconds. Those look good. But if I were doing an integral, then that would mean the integral from 0 to 4 seconds. Okay, I'm not doing an integral, so those don't look so good. So what's derivative? Derivative is rate of change. So it's the change in position with respect to time. So the distance from the origin, the radius, which is the distance from the origin, is increasing because it's positive. So you can kind of look through these answer choices and pick out something that's wrong with each one. The distance is, well, no, distance is position, and that's not, derivative is not position. This is telling me about an interval. Intervals are typically integrals, and this is not an integral question. Same thing here. And it said, well, yeah, integrals are typically integral questions, integral, those things. So those don't seem right. C is the correct answer. Okay, this one. Slope of the tangent line. Slope of the tangent line is dy dx. So this is polar, but I need slope dy dx, and I don't see any x's and y's in here. So I'm going to have to rewrite this in terms of x's and y's. What do I know about polar with x's and y's? I know y is equal to r times the sine, and I know x is equal to r times the cosine. So here's my r times sine and here's my r times cosine. So these end up being kind of messy at first. When I do the derivative of y, it's the first times derivative of the second plus the second times the derivative of the first, and then do the same thing with the derivative of the x. And then it wanted to know the derivative at the slope at pi over 4. So then things get a little bit, not a ton, but a little bit better. When you do cosine of pi over 4, that's root 2 over 2. Sine of pi over 4 is root 2 over 2. Same thing happening here and here and here and here. So you can cancel some stuff out. You can simplify some things. And from here down, it's just algebra. I mean, just algebra. It's messy algebra, but it is still algebra. So that simplifies to pi plus 8 over negative pi plus 8. So the main thing there that was like calculus, not algebra, was being able to turn the equation, the function, the curve into x's and y's, and then do the derivative of each one. Okay, this one. I want to know the area of the inner loop of this curve. I want to know this area. Not the whole thing, just that part. So I know area is 1/2 integral of r squared. And I know r is 2 minus 4 sine theta. So the only question is, where does it start and where does it stop? So when I look at this function, how do I know it doesn't start here and then stop when it gets back to there? Well, I don't. It could start there and stop there. You could pick any point and say it started here, it went this direction, and it stopped there. And that may be true, but just because it's true doesn't mean it's easy. I want to solve these things for what's easiest for me. And the easiest thing for me is that point, because I know that that point has a radius of 0. So where does this function have r equals 0? That's what I really want to know. So if I set the function equal to 0, 2 minus 4 sine theta equals 0. If I subtract 2 and divide by negative 4, I get sine theta equals 1/2. The y coordinate is 1/2 for 30 degrees. So pi over 6. In quadrant 2, 5 pi over 6. It would be negative in quadrant 3 and quadrant 4. So, I mean, we could go another circle. So like 13 pi over 6, and on and on and on. So let's try these that I've got first. So I know for sure that when theta is pi over 6, I get 0. I want to pick something in between these, because I need to know if between pi over 6 and 5 pi over 6, am I getting the inside loop, which is what I want, or am I getting the outside loop, which is what I don't want? So if I plug in like, pi over 4, so I'm just doing a little scratch work here. 2 minus 4 times sine of pi over 4. Well, that's 2 minus 4 times square root of 2 over 2. So that is 2 minus 2 root 2, and 2 minus 2 root 2 is negative 0.828. Okay, so just a reminder, what does it mean when the radius is negative? That means at a 45-degree angle, go the opposite direction. So that would be 0.8 units, the opposite of 45 degrees. So that would be in quadrant 3. If you want to try something else, you know what would have been easier to try? Like pi over 2. If I did 2 minus 4, the sine of pi over 2, the sine of 90 is 1. So that would be negative 2. So go 2 units the opposite direction of 90 degrees. What if I did, okay, I think that this is right, but how do I know, because this doesn't have units on it. How do I know that this is 2 units? How do I know that the 2 isn't down here? Well, what if I plugged in something between these two? Something between 5 pi over 6 and 13 pi over 6, like 3 pi over 2, 270. So if I did 2 minus 4 sine of 3 pi over 2, that would be 2 minus 4 times negative 1. So that would be 6. So that means at a 270 degree angle, go 6 units. So 6 units is bigger than 2 units, even though they're going the same direction. So now I can compare them to each other and say, oh, 3 pi over 2 is on the outside loop. I don't want that one. I want pi over 6 to 5 pi over 6. So that gives me my, wrong one. That gives me my numbers to use here. And now I can look at my answer choices. Okay. Well, wait. Where'd the 4 come from? Where'd the 2 come from? So when I look at the answer choices, 0 to 2 pi would go all the way around the shape. That would include everything in the whole entire thing. I don't want that. I only want the inside part. Pi over 6 to 5 pi over 6. Hey, that's what I've got. But where is this other thing coming from? And where did the 1/2s go? Because there's supposed to be a 1/2 out front. So where are they getting the 2 from? This one I think doesn't look right. Okay, so which one of those is it? Is it 2 or is it 4? Well, what happened is they factored out a 2 from this. So if you factor out a 2, then that would be 1 minus 2 sine theta squared. But 2 squared is really 4. And then half of 4 is really 2. So that's where the 2 came from. And this one is the correct answer. This one is weird looking. This is only one function. It's not 2 functions. It's a function that kind of wraps around itself, but it doesn't cross itself. So the function here is r equals theta, and I want to know just the shaded part. So if I just do 0 to 3 pi, I get the whole thing. And I actually even get part of it twice, because 0 to pi is going to include this part, and then pi to 2 pi is going to include this part, and then when I keep going, 2 pi to 3 pi is going to include all of those parts. So that little part in the middle is going to get included twice. Well, that's not what I'm looking for. So how do I set this up? I need to do this part minus this little hole. Okay, so where does the outside part start and stop? It starts, okay, this is 0, this is pi, this is at 2 pi, and this is at 3 pi. So when you guys see how I set this up, because I don't want to spend too much more time on this, the video is getting kind of long. When you look at how I set this up, the part that's shaded in yellow is the 2 pi to 3 pi part, but that would have included the hole in the middle that I don't want. Well, the part in the middle that's the hole is between 0 and pi. So I did the outside part minus the inside part, and then did a lot of algebra, and it all simplified down to 3 pi cubed. This one is another one where you had to do the outside minus the inside. So what is the area bounded by the 2? So I want the part that's in between them. So the theta one is the one that I colored in red. and the 2 theta plus 1 is the one that's shaded in blue. The blue one includes the red one, because remember, this starts from the origin and goes out to the edge. So when I do the blue one, that starts at 0, 0 and goes out to the edges. So that would include the part that's in red, and I want to get rid of it. So I needed to do the one from 0 all the way around to 2 pi. On the theta one, I needed to do 0 all the way around to 2 pi on the other one, and then I needed to subtract those two. So you can pause this and look over the document if you want to, but that's where those integrals came from. And then a lot of algebra. Okay, this one. I want the area between the two curves. So I color-coded the blue and the yellow. I labeled the points where they crossed and color-coded those two. So this part that I shaded in yellow, I could get that by doing the integral from 0 to 2 pi, and then I could double it because this part on the bottom is the same size as the part on the top. This part in blue, I could do that with the integral from pi over 2 to pi, and then double it because the part on the top is the same as the part on the bottom, and then there's the whole thing, and that's what I want to know. So when I start looking at the answer choices, though, which one looks right? Well, one of them goes, let's see, I need to add these together, first of all, so I don't need any subtraction. I'm not subtracting them, I'm combining them. So that one's out. Which ones look right? Okay, this one doesn't have a squared on it, so I'm thinking that one doesn't look so good. I think I'm going to have better choices than that. This one, I don't know where that's coming from. That doesn't look right to me, so let's just check this one. Do I have the integral from negative 90 to positive 90? Could I have done negative 90 degrees to positive 90 degrees for the yellow one? Well, I didn't write it that way, but I could have. That would work. And then could I do positive 90 to 270 on the blue one? Well, let's see. At a 90-degree angle, if I kept going until I got to 3 pi over 2, 270, that would have included all the right pieces. So even though I would have approached this differently, working it out just myself, that works too. And that is the end. And I hope this kind of helped answer some questions. If it didn't, if you still have questions, let me know.